Now we'll discuss about universal shift register. If you see examination point of view, either they will ask you describe or explain about the different types of the shift register, or separately they will ask you discuss about the universal shift register. So in this, if you see the construction here, so we have considering here for the 4 bits. So we are taking 4 multiplexer here and followed by 4D flip-flop. So since here this name itself is the universal shift register, so it is going to provide the bidirectional, means it can do the right shift, left shift, as well as it has parallel loading also. So in case of multiplexer, what we are going to choose, it has 4 inputs and it will have 1 output. So since inputs are 4, so selection lines, this one we can write to the power 2 cross 1. So number of selection line will be how many? That is also 2. Number of selection lines. So that's why if you see that here, 2 selection lines are there, S0 and S1. Same selection lines are connected to all multiplexers. And it has 4 inputs, that is marked as 0, 1, 2, 3. And output of multiplexer, each multiplexer is connected to the corresponding input of the D flip-flop, and here each same clock pulse is applied to the flip-flop. So that is the concept of the synchronous here. And if you see that later, if we'll discuss how this different selection line is going to control the operation of this universal shift register. When selection lines are 0, 0, there is no change. Means what is the previous one? Whether it is performing right or left shift or parallel loading takes place. So it continue the same operation if both selection lines are 0, 0. Next we have combination 0, 1. Then it will perform the shift right. 1, 0, shift left here, and 1, 1 parallel load. Generally, if you see that, suppose for example, in case of shifting, suppose it is the pipe, water pipe we are taking here, and that is kept at the same level. Now, if you'll pour the water from the right side here, so this water flow will take place where? Left side. So this will perform which type of the shifting? That will perform the left shift. Similarly, if suppose for example, if you are going to pour the water this side and water has same levels here, so finally we'll get water from the right side. So that will perform which type of the shift? It is going to perform the right shift. On the basis of this, we are going to see here how this universal shift registers are going to perform the different types of the shifting. So first we'll take the examples when we have selection line combination is here, that is the 0, 1. That means if you see that here we have S1 as the 0 and S1 is the 1. So it will perform the shift right. So in this case, if you see the connection here carefully, the output of each flip-flop is connected to the 0 input pin of the multiplexers. So everywhere it will have see similar connection is there. Output of each flip-flop is connected here to the port 0 of the input of the multiplexer. Now when we are going to perform the shift right, and here data input takes place serially, that is given to port 1 of the multiplexer. Now whatever input is given to the port 1 here, and here if you see that here this combination is also going to give us decimal 1, 0, 1 is equal to decimal 1. So that's why it is going to take the input from the port 1, and that input will be available at this values. Suppose for example, now we are going to take one value as the 1 here. for example. So in this case, now this one is the input that is available here, and the same is given input to the D flip-flop. Again, it is available here at the output of this D flip-flop. Now, if you see that it is connected back here to the port 0 as well as port 1 of the next multiplexer. So what is the output of the previous flip-flop? That is going to be the input to the port 1 of the multiplexer. So finally this is one is input here. That one is going to come here. Again same one will be the available at the output of this flip-flop also. So now again this flip in the like clock pulse is going to change, keep on changing here, and here we have positive edge trigger. So now if you see that this one is going to be the here again input here to the port 1 of the next multiplexer, and that is available as the output, and again same is input to the D flip-flop, and finally again A1 is also 1. Again this A1 is connected here port 1 of the next multiplexers, that is fitted here, and this is available at the Y, that is output of multiplexer. Again it is input to the D flip-flop, that is available at the A0. So like this first bit we are able to get here at the output here at the A0, and in the same time if you see that already we have seen how this in case of serial in and serial out, how this shifting takes place. In that way also we can observe, and this is going to work as serial in and parallel out also. Parallelly we are able to get the output from here, so that consecutives, so when it is going to work as serial in serial out means at the end of the fourth clock pulse or after fifth clock pulse we'll get the first LSP output here from the rightmost flip-flop. But in case of, we have seen that in case of serial in parallel out, at the end of fourth clock pulse, we'll able to get the all data input as the output. So here A0, here we'll get the LSB, and at A3 we'll get the MSB when it is going to act as the serial in parallel out. So like this discussion is about when it is performing the serial input and going to perform the right shift. Next we'll see the another situation when it is going to perform the another task. So that we are considering here shift left. So for this shift left, S1 is 1, S0 is 0. So this band equivalent is what here? 2. So that's why again if you see that here right side, here it is connected to data input is connected to the port 2 of the multiplexer. Now again similar situation when suppose for example here 1 is given as the input. So that input is available at the port 2 of the multiplexer, and that is available at the output. Same is the input to the D flip-flop which is available at the A0. So now first LSB bit you can get here in case of serial in parallel out. Now again if you see back that this A0 is connected here the port 0 of the multiplexer as well as this is again if you see that is connected to the port 2 input of the multiplexers. So same, what is the output of this flip-flop, rightmost flip-flop, that is available now as the input here. Now again same selection line is there 1 0. So this 1 is available at here at the output of the multiplexer, that is going to be input. Again it is going to be the output here. Again if you see that this is connected back here as the input to the port 2, again it is the output. So this process will take place, and again at the end of fourth clock pulse we are going to get that A3 as the first LSB bits here. So like this it takes place in case of shift left. So we have to observe the carefully how this connection is made. And last one we can see about this, that is the parallel loads. So in case of parallel loads, if you see that data inputs are connected parallelly to the port 3 of each multiplexers, and here selection line combination is what? 1 1. This is the decimal equivalent is 3. So that's why it's going to perform the parallel loading, and data inputs is connected to the port 3 of each one. So in the similar way, only here for the different situation, for different shifting, we are seeing that we are going to change the input to the multiplexers. And on the basis of that, output is available for the multiplexer and output is fed to the flip-flop and we are able to get the output. And output of the flip-flop is going to be the input again to the next multiplexers. Like this, we are going to observe here. And in this way, data is being shifted from one flip-flop to the another flip-flop. So the basic concept what we are using here, first of all, we have to observe the connection, how this connection is made. So that is the not difficult. So for 0 0, if you understood this mode control, 0 0 means no change is there. So that's why port 0 doesn't have any inputs if you see that here. Port 0 is connected to the output of the flip-flop and this port 0 is connected with 1. Again port 0 is connected with 1. Port 0 is connected with 1. That you can observe here. So like this, we can make the connection and same selection line is given. So finally, on the basis of this selection line, we are going to provide the input to the multiplexers. So particular pin, we are going to provide the input. So port 0 doesn't have input. Port 1 having input for the right shift. Port 2 having input for the left shift and port 3 having input for the parallel loads. On the basis of that, we'll get the output and that output is given to the flip-flop. And since it is the D flip-flop, so what is the input that will available at the output? And finally, again, that is going to be the input to the next multiplexer. That we have to keep in mind in the connection. Like this, we are able to perform all type of the shifting here with the help of universal shift register. It can also be designed with the help of decoders and other combinations, but I hope it is the much easier to understand. And in the sequence of this, other shift registers are also explained. You can observe in other videos, and these are the very, very important topics. Thank